Hi everyone, it's Tojo, or Tarek, and I'm going to briefly go over the design document, and then show my website, and then show some of my code. So, the goal, or the objective of this project, was to develop a website that provides an accessible interface for machine learning model inference. So I already have some machine learning models, like 4 of them, that were trained to distinguish between native and non-native bird species found in Hawaii. So the primary utility is to allow users who encounter an unfamiliar bird to upload a photograph to the website and quickly receive some sort of binary classification, whether or not the bird is native or non-native. For inference, I'm using TensorFlow.js. The trained models live as JSON files on GitHub Pages, and GitHub Pages serves them like any other static file. Basically what TensorFlow.js does is it downloads the models into the browser, and it also pre-processes the images that the user inputs. So the models do inference and runs their predictions using the browser. So for the front-end stack, I'm using React and TypeScript and Vite. And for styling, I didn't use Sass or SCSS because while I was doing the project, I realized that everything that I wanted to do can be done with Tailwind CSS. For the deployment, I'm using GitHub Pages. The aesthetic is a minimalistic and professional feel with mounted borders. I wanted to use a color palette of basically blues, black, dark blue, light blue, some gray and white. And let's get on to the website. Alright, so this is the website. The Hawaii Bird Classification title is on the nav bar, and the nav bar also has a bunch of pages. So the home page is for model inference. The user will upload an image to classify native versus non-native bird species. So I used React drop zone to create something where you can either drag and drop an image or search for it with a file path. And then there's a final prediction line here that's blank. These are 4 different models: VGG, Inception, ResNet, and a custom model. Their predictions are all nans right now. So I'm just going to drag and drop a bird image here. This bird is a pigeon, and the final prediction is that it's non-native. And each model individually predicts the value for the pigeon. If it's a value that's closer to 0, then it predicts non-native, and if it's a value closer to 1, then it predicts native. And so for this final prediction, what I'm actually doing is I'm taking the mean of my 2 best models, Inception, V3, and ResNet, and that mean is 0.02, so there is a 2.8% chance that this is a native bird. And for the final prediction, what I'm doing is just a threshold. So if it's a value between or less than 0.4, it is non-native. If it's 0.5 to 0.6, then it says uncertain. And if it's a value between 0.6 and 1, then it'll say native. So here's the models page. You can explore the neural network architectures used for classification. So for the 4 neural networks, or the 4 models, you can click the View Architecture button, and you can compare any number of architectures that you want. And there's overflow here. You can also click a link to see the research paper for the particular architecture. Or you can look at documentation. So you could also learn how to train each model, or at least learn about each model. Yeah, and the order at which you click the buttons is the order for the architectures. You could also view results. So this is a rock curve for VGG19. It's just an image. You can also compare results between models. So the 2 best models were Inception and ResNet. For the birds, I have a bunch of cards that each contain a bird image, the common name, the scientific name, and whether or not it's native or non-native. You can filter them by native only, introduced only, and as you can see, when I press introduced only, if native only is toggled, then it'll toggle it off. Because if both were toggled on, then there would be no pictures of birds. Then to see all birds, then you would just press the button that was already toggled. You can also show a birds table, which is basically the same thing, just without any photos. And here's my abstract page. It's just text. So I have a problem statement, I have data, where I got the data from, how I pre-processed it, how I trained the models, like some of the results from the models, and future work. Future work is also in this upcoming tab, where I say that this is future improvements and research directions. So an example is multimodal methods. Classification currently takes as input images only. Integrating data such as geographic location, daytime of capture, and sound of the organism could improve predictions. And this is high priority to get this done. I also have medium and low priority. And then here's the contact page. It's just my name, my GitHub, and then a link to the repo. And as you can see, there are two branches. You have a main branch with all of my source code, README, and I also have a GitHub Pages branch that only includes things from the dist folder. Now let's choose a random bird here to see if the model can identify it correctly. So I know the Mino bird is very common, and there must have been a lot of photos used to train the machine learning model. So let's look up Mino bird. Drop. Yeah, non-native. Let's look at a native bird. Let's do that. So the models actually work pretty well when you give it a bird that was used in the training data set, so any one of these birds. The files live under the source folder, under the components folder, and I have a page that's correlated with one file, and it's .tsx because we're doing TypeScript. I'm going to use birds as an example. In this birds.tsx, I have a bird card, and this bird card correlated with one of the images of the bird. You can see here that bird card is called within this map function, and this map function is called for each species. And this variable species, if we look at databirds.ts, is just a list of species, and species is a type that has 3 keys: scientific name, common name, and native. So basically the species list is all of the information in each card. So if we go back to birds, what I'm doing is I'm basically doing the equivalent of a for loop that returns an array. So that's the map function. I'm mapping over each species, filtering out based on which button is pressed, and I'm creating a bird card, and this bird card is this other separate function here that includes an image, it includes the common name, the scientific name, and whether or not it's native, and have some typing with TypeScript. So this function species is of type species. So yeah, so there are typings in here, and you can see that within these elements I have class name. So in React you change class to class name, and each of these class names I'm using Tailwind. So I didn't actually do a lot of CSS. You can see my index.css is 22 lines. It's not that much. All I really did was in my JSX, which looks like a bunch of HTML, I put a bunch of Tailwind classes. Yeah, I think I'm supposed to talk about how much time I spent doing stuff, and I think that I spent a good amount of time learning React and Tailwind, and it's hard to get started, but as you can see from the website, I have a bunch of rounded borders. I used a lot of the same Tailwind styling, the idea of the cards. Once you figure that out once, you can kind of just do a variation of it, and you can see that I have cards for models, I have cards for birds, cards for upcoming. So once you figure out how to use flex and flex call and justify center and item center, then it's really fast to do it again. So I think it was a good practice for in terms of using Tailwind. I think that's all I wanted to talk about. Thank you.